we're going to be talking about pH math here. So the concentration of hydrogen is 1 times 10 to a negative something, and that something is pH. So this is like your first core understanding here, and there really doesn't need to be much math on this part, because this part you're just like figuring out, okay, here are my examples. If I'm trying to get to pH and I have these amounts of hydrogen, all you are doing is you are realizing that pH is this number here. This is the pH, that is the pH, and that is the pH. And the reason is because it's at 1.0 times 10 to that power. So number 1, the pH is a 1. Number 2, the pH is a 5. Number 3, the pH is a 13, because those are the numbers there, and it is 1.0 times 10 to that number. Now, if the pH is a 1, we have an acid. pH of 5, we have an acid. pH of 13, we have a base. So keep in mind that, because many times it's going to ask you, is it an acid, is it a base? So this is kind of like just understanding what pH is. pH is a negative exponent of a times 10 when we talk about the hydrogen ion concentration, which is why the bigger the pH, like this 13, it actually means the smaller amount of hydrogens, because the negative 13 is like a ridiculous amount of zeros. I mean, it's sitting there and saying, you know, you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, yeah. So, and then you got your 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then it hops here to the 13th power. So you have this many moles of, or this many molar for hydrogen. So yeah, it's like incredibly low when you have 10 to the negative 13. So that was kind of like a little like explanation for you. All right, and then when we take a look at this, you can see there, those are the answers. You'll notice in this, they're color-coded. Hopefully they will be so when I do the updated Google Slides. If I have a pH where there is no decimals, if I have a pH where there's no decimal, then we can still use this idea and say, okay, well, it's 1.0 times 10 to the negative 4, because this 4 is the pH, which means it goes right there. Whereas this is 1.0 times 10 to the negative 11, 1.0 times 10 to the negative 7th. Okay, and all of these are technically molar, so, you know, big capital M, capital M, capital M. And negative 4, pH of 4 is an acid, pH of 11 is a base, and pH of 7 time you're at a neutral solution. Exactly. So this is just interpreting what pH is and writing it down. Like, I didn't need my calculator, I didn't need any math to do this. This is just the idea of what pH is. If we have a pH where the pH is not a whole number, if it is a decimal, you may be tempted to do the simple thing of just saying, okay, that's fine, then that means it's 1.0 times 10 to the negative 4.3. You may say this, you may be like, this is great, this is good, but here's the thing, no, it's not. No decimals or fractions in your exponents, none. You can see it's written up there. It should be written in your notes. No decimals or fractions in exponents. Never. That is a math no-no. Don't do it. So instead, what we're going to do here is you're going to type in, first off, you're going to be in scientific notation. If you know how to do that, it'll make your life a lot easier. Then you're going to type 10 caret, if you have a caret. If not, you have to figure out how to get it to the exponent level. Negative, whatever the hell the question tells you. In this case, 4.3. I don't know why my pen sometimes does that, but sometimes it does. All right. You're going to want to type in your calculator 10 caret negative 4.3. Then you're going to hit equals, and it's going to spit you out an answer. So I'm going to change my calculator into scientific notation. This is equal to 5.0 times 10 to the negative 5th power, and that will be molar. And this here is my answer. Just like that. Again, all I did was 10 caret negative 4.3. I put that in my calculator, and I get my answers right here. So there you go. That's all it was for this in my calculator. So these ones are all fairly easy once you know the trick. And again, the reason this is that way is because we are going from pH to the concentration of H. So that means it needs scientific notation. That means it's 10 to some power, negative, whatever the heck the question gives you, acid, base, or neutral, as it is. Now, part 2, the next one is, what if we're going the other way? What if we are going from concentration of hydrogen to pH? Now, the nice thing here is you should be in normal notation. So it should just be called flow or normal, maybe English if that's what your calculator says, whatever. So normal notation, standard notation. So you get this. All you have to do, okay, yeah, it didn't show it, that's fine. All you have to do is type in negative, find the key, hit that, and then type in whatever the hell the problem tells you. Or I should say, whatever the heck the problem tells you. My apologies. So you type that in. So all I did was negative log 2.3 times 10 caret negative 7 in parentheses equals, and it spits out a number with lots and lots of decimals. But again, we don't want that. We want to make it so that we only have a certain amount of decimal. In this case, it'd be 2 because we have 2 here, but again, 2 or 3 will work. So the answer to this is 6.6. And 6.6 means we have an acid because it is under 7. All negative log, whatever the heck it is. In this case, we are at 8.3. And at 8.3, we have a base. So we just took care of the left side of our concept map. So that's done now. Now what's neat about that is the left side is identical to the right side as long as we're dealing with POH and concentration of OH. Measuring hydrogen, I'm measuring hydroxide. So it's going to flip it. High levels of POH gives you an acid, not a base. So it's going to be flipped whether it's above 7 or below 7. What happens when you have H3O+? This is the same thing as H+ as long as it's in water, and you can always assume that it is. Basically, if you see H3O+, which is hydronium, that's the same thing as hydrogen. You know, you're going to go to pH using your negative logs. You're going to go to the concentration using 10 to the power, negative power in scientific notation. Nothing changes with this except how it's worded. And I have to show this to you because some of the people who work on the final exam like to word it this way with hydronium. I prefer to word it with hydrogen. It doesn't matter, it's the same thing. Now, here's a new thing. This is where the number 14 comes into play. You can swap between pH and POH using the number 14. 14 minus what you have equals what you want. That's how we can get from P of one thing to P of another. So with what I've got here, all I'm going to do, since I'm in standard notation, is take 14 minus 13.3, and shock, you get 0.7, because that's it. And so this here has a pH of 0.7. And you just keep going. Okay, this one is 7.3. Oh my lord, it's going to be a pH of 6.7. 2.5 is a pH of 11.5. 11.5. So that's it. It's 14 minus what you have equals what you want. And it works the other way too. If I've got POH, it's the same thing. 14 minus what I have equals what I want. So 1.1 will give me a total of 12.9. 4.9 gives me 8.1. Wait, no, hold up, 8.1? No, I think I goofed that one. I think it's 9.1. Every now and then, if you need to go back and use the calculator, go ahead and do so. Better to do that than be right. Yeah, it's 9.1. Okay, good. Caught myself, but still, it's a little embarrassing. And this is just 0.9. Of course, I could have just clicked the thing and showed you all of that. Now, you will notice, here we go. I mean, all the numbers were right. But notice, less than 7 pH is acid, but greater than 7 pOH is acid, because pOH and pH measure opposite things. So you have to keep that in mind, that low pH is acid, low pOH is base. High pH is a base, high pOH is an acid. And now we did the top, right and left. But what if I want to go from concentration of H to pOH? Well, the first step I would do is I would turn it to pH, then I would turn it into pOH. So see, 1 step, 2 step. So everything here can be done in 1 step or 2 step. You should never need 3 steps. In this case, if I want from pOH to go to H+, I start by changing it over to pH. That's my first step. Then I calculate it in scientific notation to get my answer of concentration of H+. So I had to do 2 steps. I had to get it to pH, then I had to get it to H+. 2 steps got me the answer. 2 steps. So be careful and watch that. So for these ones, you're going to need to do your 14 minus as your first step, and then your second step, you're going to do it to the negative power. So this is your 2 steps. Now, going the other way, if I have the concentration of H and I want to go to pOH, what I need to do is the negative log, because that will give me my pH. Once I have pH, I then do the 14 minus, which will give me my pOH. I really sound like I'm speaking some foreign language, because I am speaking the language of chemistry, which is a language of numbers and written word as well. So I know it's tough. Don't give up. Do your best. Use the concept map that I provided. It's very helpful. I get that from years of teaching this. Now, if we are going from OH or pOH, sorry, if we're going from pOH to OH, this is what this is. If I'm going from pOH to the concentration of OH, it's the same thing as we did when we went from pH to the concentration of H. So what I'm going to do here is I'm going to sit there and go, okay, I want to be in scientific notation, and I want to do 10 root negative, whatever the heck the problem tells me. 10 root negative, or 10 caret, not root. 10 caret negative, 10 caret negative 10.9. And then when you hit equals, you will get these numbers. 1.0 times 10 to the negative 7th, which makes this neutral. 1.0 times 10 to the negative 2, which makes this a base. And 1.3 times 10 to the negative 11. Acid. Again, we're in OH, so we're in oppositeville. Now, I can go the other way if I'm trying to go from OH to pOH. So this is me going from OH to pOH, which is the same as going from H to pH. All I'm going to do is type in the negative log. So again, all of these are just negative log questions, negative log, and then type in whatever that is, and boom, you get answers. Let the calculator do the heavy lifting, have a decimal place, and you're done. Or don't, or keep it in 2. You've got 1 decimal flexibility, you should take advantage of that. So this was all the same here, and the thing is, there's still more 2 steps. but it's the same deal. I'm going to change this from pH to POH. Then I'm going to change it using my calculator to OH, to concentration of OH. Same as we did before. Just like the other one, negative log to start gives me POH, and then 14 minus what I got gives me what I need. So again, this is two steps, more complicated, but this is how it goes. This is how we roll. Now we're going to talk about doing the bottom. The bottom, where we go from the concentration of one to the concentration of another. From concentration of H to concentration of OH, or concentration of OH to the concentration of H. This is what you do. Whatever you want is equal to 10 to the 14th over whatever you have. Done. Not that bad. Pretty easy to do. So again, okay, this one doesn't come up for me, but that's okay. I will write it out for you. I am here, and that's why I am here. Okay, so again, when we do this whenever we are going from, I'm sorry, that wasn't on pen. Pen, there we go. All right, so this is whenever I'm going from one concentration to another concentration. All right, so all I do is I take 10 to the negative 14 divided by whatever we have. That's it. That's all I do. So I take my calculator. I do 10 caret negative 14 divided by 10 divided by whatever the heck that problem is. Put in parentheses, because math underneath the decimal needs parentheses. So I put that in parentheses, and I hit equals, and I should be in scientific notation if I'm not already. It's out an answer, and that answer is 1.4 times 10 to the negative 8, and this one would be 2.1 times 10 to the negative 4th. This is a reminder that one pH is a 10 times change because each of those pHs is an exponent. This is an exponent of 10, which is exactly why all of this math works. You can see here at the center where my mouse is moving, you've got your standard notation, your scientific notation, depends on where you're trying to go. If you're trying to find P's, whether pH, POH, either of those, you want to be in standard notation on your calculator. If you're trying to find the concentration of hydrogen, the concentration of hydrogen, or switch between the two, you want your scientific notation. So whether you're in standard notation or scientific notation, it should tell you each time here on the map what you should be in. And this is how we can go from pH to POH to the concentration of OH to the concentration of H back to pH.